Hey, hi, I'm Dr. Ezrailson. I was a science teacher for many, many years, and I taught at the U, and now I'm retired, but I still love science. So what I thought I'd do with you today is talk about rivers like the Missouri River that we have conveniently available to us in Clay County Park, and how you could make a model of a river and learn about some parts of a river and why they have different features. Um, First of all, we can look at some of the equipment that you might need. Something like an aluminum pan, piece of foil, some water that's been tinted with food coloring, maybe the cover for the aluminum pan would be very useful because we're going to pour water into it when we make our model. We have to hold things down today because the wind is quite fierce. So, why do you think a river runs faster or slower? There are a few reasons that I can think of right off the bat. One reason is that the river is tilted compared to the plane that it runs onto, or compared to the elevation or height of the larger river it runs into. And with our model, we can use a container to tip it up and give it an angle. So it would run faster or slower depending on how high it tilts. We can talk about the height or elevation of a river, and that's the difference between where the river starts and where the river runs out, whether it's in a stream or on a plain somewhere. Well, we're going to use our model to talk about also some other features that would make a river run faster or slower. I just talked about the elevation or the angle. It also depends on what's called the depth or channeling of the river. If the river is deeper, depending on the elevation, it may run faster or slower. In fact, a deeper river probably has a couple of levels at different speeds that run in different directions. Complicates it a little bit. Okay, so we're going to make our channel for our river out of foil. Notice that my foil is fairly thin strip. And how do I know how long to make it? Well, I used a couple of pipe cleaners that I hooked together. And I wanted to make a shape of a riverbed. Wanted to make the shape of the riverbed with a curve in it. And there's some reasons why a riverbed would have a curve. One of the reasons is that it got shallower where it was running into. And when it gets shallow, it kind of spreads out over a plain. It starts to meander or wander around the plain. And then the water slows down. And in fact, if you notice next time you're at the river, if you go around a curve, you'll notice that there's a lot of debris, whether it's rocks or boulders if the river was running fast when it dropped the debris, or whether it was silt or clay that collected there when the rivers flowed down, because slower rivers cannot carry as much weight or mass. Okay, so we're going to make our river with a curve. And we're going to use the cover to let our river run out. Now we're going to need some water, and if we want to get fancy, we could use some rocks and some dirt and some leaves or sticks or whatever, and you can make it really fancy and look nice. But these are the basic parts of the river. So we talked about the channel. The amount of water that runs in the channel is called the volume. And so if the volume is greater, it's deeper. If the volume is less, it may be shallower. All depends on how it's running. Now, we're going to measure how a river runs faster. Think of a couple things we could do to make it run faster. If I already said if we gave it a bigger angle or a greater elevation, that it would run, the water would run out faster. If we gave a lower angle or less elevation, it would slow the river down. You could make this as a hypothesis. What's the hypothesis? Well, it's an educated guess about what we think will happen when we have an idea. In science, when we get an idea, it doesn't mean just because we have an idea it's true. We have to test it. Making a model is one way to test it. So we're making our river model to test, is it true that if the river will run faster if it's at a greater angle, or slower when it's at a lesser angle? We can test that. We can also test, does it slow down when it goes around the curve or not? And we can use our handy little cell phones, if we have them with us, and use a timer on it. Go to the clock and select the timer. And then you can have somebody time you as you pour water in the one side of the river, and we're going to make some holes in the bottom of it, or where it runs out into the plain, and see how long it takes. You could also even measure the volume of water that you're going to introduce into the channel. And water is 1 gram per cubic centimeter. It's our standard for density. And any volume of water will have a similar volume of similar mass to volume ratio. So let's tape this down. Depending on the wind where you are, you're outside, sometimes you have to hold on to stuff as it blows around, or have a few more hands. That's why it's good to have a lab partner when you're in science class, or two. I'm going to roll this around and make a little tube and stick it down so it doesn't move. Now, I am going to put it against our container to give it elevation, but how is the water going to get out? It's not going to come up and over. We have to punch a couple of holes in it. So you will need, like I said, the pipe cleaner, a measuring instrument, some blue food coloring, maybe some sunglasses if it's sunny, a scissor, some foil, tape, and I'm using a corn holder to make the holes in my pan. Now remember, if you get too excited and make too many holes, the river will run out faster. So we're not going to make very many. I'm only going to make 6 small holes in the channel. Now, all right, the next thing I'm going to do is to introduce the water. Now, I could measure it out. In this example, I did not measure it out, but you could make it more of an experiment if you measured the amount of water coming out and then timed how far it went, and we could then find out the velocity. If you tint the water, you can see we have a little waterfall happening at the bottom of our pan, and our water is not running out really fast. You could also slice a slot in the side of the pan and stick the foil through, and it would come out in more of a volume at a faster rate. So it's not just tilt, it's not just the amount of holes you put in it, it's the rate of flow of the water. You can raise it or lower it by making your model a little different. And sometimes it doesn't work out and you have to start over. So start with double the equipment so you can change your mind when you find something else works the best. Okay, so we've defined elevation. We've defined meanders, that's the wandering of the channel of a river across the plain. We've talked about the volume of water, more or less. We've talked about the velocity. We talked about the mass of water. We talked about timing it. I know that you'll have a lot of fun with this model and you'll learn a lot more about how rivers function and how we look at them too when we know more.